My shoes keep on slipping on the concrete when it rains. I better study the tribology of its soles. Tribology. 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 As you may have guessed from the context clues, tribology is not the study of tribes, but it is the study of materials rubbing against each other. For example, the materials of the rubber of the soles on my shoes sliding against the concrete on the wet floor. The study of that interaction is tribology, and it's actually not that specific. It's a study of any materials rubbing against each other. It has to do with friction and all sorts of things. The word tribology comes from the Greek part. That ology part is the study of, but the tribo part, that's Greek for I rub, as in two things rubbing together. So whenever you study that in engineering and science, that's called tribology. It's really important in cars, for example. The word started becoming in fashion in engineering industries in the middle of the 20th century because of things like cars and manufacturing equipment and planes and all sorts of devices that rely on bearings or two things rubbing against each other, sliding against each other. Think of a car engine. You've got pistons moving up and down inside cylinders, and you better not have any gumminess or friction slowing that process down. You lose a lot of energy. And so you might study its tribology of those surfaces rubbing together. You might study that certain combinations of materials have great friction properties or reduced friction, like plastic sliding against metal, for example. That's why when you look at certain door hinges, you might see a metal hinge with a little bit of a plasticky sleeve in the middle to try and reduce the friction in there. You know, in tribology, it's not just the study of friction, though, because otherwise, why wouldn't you just call it frictionology? It's a study of friction, but it's also a study of the particles that might come off of the materials as they rub together. I studied tribology when I studied medical implants, for example. Imagine you're replacing the hip of a patient. Like, you know how when you get older, the cartilage in your hip joint might be wearing thin, and then you have bone on bone rubbing together? That's pretty awful. Horrible tribological properties there. And if a surgeon goes in and replaces it with a metal implant, well, you can't just have metal on metal. Certain combinations of metal rubbing against metal, like titanium, for example, they have really bad tribological properties. They might start out smooth, but as you rub against each other over time, little particles come off. They get into the bloodstream or they get in between the two surfaces, and eventually it wears away and it gets rougher and rougher and the friction gets worse and worse. The person who studies this interaction studies tribology, and we have to find proper materials that have great wear properties, that have great tribological properties, that don't release little particles over time that you can see with an electron microscope. It's pretty awful. So the study of tribology is becoming greater and greater. It's becoming more important as we need to know how materials move against each other and behave over time. That's our engineering word of the day, important to mechanical engineers, biomedical engineers, aerospace engineers. Tribology. Hello, this is your host, Pius Wong. Go on over to engineeringwordoftheday.com to find out how to subscribe to this podcast and share it. Also, listen to the K-12 Engineering Education podcast over at k12engineering.net. Both great podcasts, all about spreading engineering knowledge to everybody. So, have a great week, and keep on thinking about engineering.